Hi, this is Nitai Gaur Mohalik, your instructor. Today's topic is about microcontrollers, PLCs, Fieldbus, and SCADA. PLC stands for Programmable Logic Controller, and SCADA stands for Supervisory Control and Data Acquisition. This is a little review about the microcontrollers, microprocessors, field bus technology, SCADA system, and also PLCs. The right hand side shows the microcontrollers, images of many microcontrollers that are available in the marketplace, and the left hand side bottom 4004 was the original microcontroller that was developed in 1971, and progressively there have been lots of different types of microcontrollers available right now. And the left hand side on the top, the square, that in the middle, as you can see, the processing hardware is actually the microcontroller or PLC or field bus or SCADA system. This is the main logic system that is being used for any kind of automated system, and others are kind of building blocks like sensors, actuators, signal conditioning circuits. You can read them, and those are the basic infrastructure that is required in order to develop automated system, such as in a robotic platform or manufacturing plant or industrial process control systems. So we need main logic or the core control action in order to implement the control systems. The processing hardware for main logic system can be categorized under four categories. The top one is relays, logic gates. Those are usually not used. Long time ago they were used for implementation of the control actions. Then microprocessors and microcontroller came, and again PLC computers, desktop PCs, powerful computers are also being used in order to control the plants. And finally, the fieldbus technology and supervisory control and data acquisition are the recent developments. Right hand side, all the images that you see, those are the the applications like military, automobiles, industrial control, robotics, chemical industries, food processing industries, medical devices, appliances, home appliances, like that. We need microcontrollers, PLCs, or field bus systems or SCADA systems in order to implement the control actions, and those are called processing hardware for main logic. For implementation of any kind of automated system, we need a microcontroller. Microcontroller is the main thing that is also being used in field bus system, also in SCADA system, also in PLC systems, right? So microcontroller, within the microcontroller again, we have CPU, and the outside that you see here in this application or in this example, robotic example, that we need PWM, for example, pulse width modulator, in order to regulate or in order to control the motor, for example, electrical motor, analog to digital converter, because we have analog signal. And we obviously we need memory. Left hand side, as you can see, ROM, EEPROM, PROM, RAM, hard disk, magnetic memory, those kind of thing we need for any kind of control implementation. And the main building block here within the microcontroller is the CPU, central processing unit. And there are ports and interrupt controllers and IO ports. IO stands for input and output. And PWM is very famous, very important terminology that is being used in automation systems. It's called pulse width modulator or pulse width modulation, that is being used in order to regulate or in order to speed control the motor that is governing the control action within the industry or within the plant. This is a clean version of the previous slide. What you see here, the same application, and there are only wires outside, and everything is now inside the microcontroller. So last time you saw the CPU, central processing unit, and outside there were PWM, pulse width modulator, analog to digital converter, IO port, like that. So all those building blocks are now within the microcontroller itself. So the microcontroller has also CPU and all the building blocks. Now, now included within the microcontroller. Obviously, outside you must need memory. Within the microcontroller there are memory as well, but that memory is very limited. So you need memory outside the microcontroller. So it's the same application, but you have to understand that the additional building blocks that is required in order to implement the control actions, that is now within the microcontroller itself. What you see here in this image, it's actually the inside of the CPU, central processing unit. You don't have to remember anything here, just to take a look that okay, within the CPU there are many building blocks, and I have listed all those building blocks right hand side. So it includes accumulator, it includes temporary register, arithmetic and logic unit, instruction decoder. So these are, and also temporary memories inside the CPU. So these are required, and they have been connected in such a way that everything flow works. Flow, what I mean by flow is that whenever you write code, then this CPU must execute those codes, okay, based on your program. So they have been designed. You don't have to think how they have been designed, but just to have a kind of little knowledge about what are inside. So since this is a micro lecture, so I don't want to explain right now. So if you would like to dig into what those components are, what those building blocks are, you can uh, do. And I have posted all those information in there. So the most important here is ALU, arithmetic and logic unit, and instruction register, which brings the instruction from the memory and executes and then operates. Okay, and these building blocks, there are actually 12 important building blocks must be there within the CPU, and I have listed all those here. The last slide was the CPU, and this slide is the microcontroller. As I have mentioned that within the microcontroller you have additional building blocks such as PWM, analog to digital converter, digital to analog converter, and also the IO port, interrupt controller. And on the top of 12 basic building blocks um, that should be there in the CPU, this microcontroller has additional building blocks which are required in order to implement control systems. So this microcontroller is known as 8XC196KC microcontroller from Intel Corporation. It is a 16-bit microcontroller, very popular. Most of the appliances, they use this kind of microcontroller. If you need any microcontroller in future for your application, so I suggest you use this one. This is really a good one. As I mentioned you earlier that microcontroller developments over time, I have listed here the developments. Early microcontroller 70 to 80, 80 to 90, 2000 to present. So three categories I have listed. So please take a look, and you can also search the net and then find the details about all those microcontrollers. This is a PLC. PLC stands for Programmable Logic Controllers. It's not a microcontroller, rather a PLC. And the meaning of PLC is that it has, CPU also inside, and also memory, output modules, and input modules. What it has inside, actually lots of relays. Relays are nothing but the switches. If you go back to our fundamental theory, that any logic you can implement using the switches. Okay, that's important to know. So all the logics, any kind of logic, for example, what is the meaning of logic? Logic means if, when, then do something. If this occurred, then do something. When this happens, then do something. So this is a kind of logic. All the automated systems play game around logics. Small logics, large logics. All the larger logics can be segmented or divided into smaller logics. So all your programs, actually, they are logics. Based on the logic, you are developing the program and writing the code, and the controller executes all those logics, uh, you know embedded into the program. So everything that, if you think about logic, then it's nothing but kind of switches composed of lots of switches on and off, on and off. So these controllers, they have internal architecture, hardware. They can execute all those kind of on and off things in a very sequential and a logical manner. Okay, that's why all the PLCs or microcontrollers, they have inside kind of simple binary systems or digital systems, but it's digital, on and off, 0 and 1. Okay, so we have already studied all those things. So a programmable logic controller is an industrial digital computer used to automate manufacturing processes, machineries, and systems. It monitors input, processes logic based instructions, and control outputs in real time. PLCs are reliable, programmable, and widely used in industries like automotive, energy, and robotics for efficient automation and control. So within the PLC, they have most important four things like input module relays. As I said, relays are nothing but the switches, and also output module relays, and CPU and memory. Fundamentally, the PLCs can be thought of as a cabinet consists of thousands of relays, counters, timers, and memory cells. As you can see, this is a cabinet. Looks like a cabinet, right? And this is PLC. Let me talk about the Fieldbus technology. A Fieldbus technology is actually a control networking system using which you can implement a distributed control. What is the meaning of distributed control? It's not centralized control, meaning that all the microcontrollers, they are connected into network. So here, what you see in this application, this is a packaging line application. It has a robot, it has conveyor belt, and it has a motor. So all, and also sensors. All these sensors and motors are called actuators. Sensors and actuators are connected into a network, single network, and it's called Fieldbus. And what you see here, N1, N2, N3, N4, N5, these are actually the microcontroller. They are connected to sensors, and other end it is connected to network. So the difference between the centralized system and the distributed system is that you have here only one networking system instead of one to one wiring. So you can save the cost. So distributed control system has many flexibility. You can program one node and then replace another node, so while the other node is working, so like that. So it has flexibility. Distributed control has flexibility. That's why the field bus technology has very popular among any other control infrastructure or control systems. Okay. Let us know about supervisor control and data acquisition, which is called SCADA. SCADA is actually used for large scale applications, and when I think about no utility networking system, airport automation system, household water supply systems, supply chain transportation monitoring system, or traffic security control system. These are the large scale applications where you have more than thousands of nodes, thousands of controllers connected into network. Unlike Fieldbus is a smaller system. SCADA is a larger system, meaning larger technology, meaning that it has all the ingredients, all the infrastructure, including the microcontroller, including the networking system, including to accommodate all types of data transmission, data communication, multiple interfaces. So it has all ingredients: hardware, software, communication interfaces, protocol, everything. So it is used for very huge applications, large scale applications. This is the last slide, and we covered all these four aspects: microcontrollers, PLC, Fieldbus, and SCADA. So please explore more about all these topics, and I have posted all in the canvas or in the course site. Happy, joy, joy. Bye.